Okay, welcome to the second German presentation. Not in German, lucky for you. Everything's done in English here. But I'd like to welcome Tobi Wulff, and he's been working with Python, kind of programming and writing scripts for about 10 years now. And at work, he uses Python for automated testing of network switches and routers. So now he's going to talk to us about how you can control all your programs with MIDI controllers.
Hi, so yeah, I'm going to not actually specifically talk about audio programs, but MIDI controllers are basically have been designed for audio scenarios, and I've hacked something together that I'll present through this presentation at the very end that enables you to, in theory at least, control any application through the help of Python with those MIDI controllers. So MIDI controllers, the ones I specifically want to use, look like these. They're actually pretty small. It's just like a small mixer board and trackpad thing that's this size. Connect to a computer via USB. And I started editing or developing digital photos with raw photo software, Darktable. And I thought, oh, maybe I can use those mixers, those sliders to adjust things like brightness, saturation, turn on and off certain effects. But the software I was using doesn't, because it's not an audio software, it doesn't have any interface, any API to talk to MIDI. So we needed something in the middle, and there's some cool Python libraries out there, and just with Python in general, it was pretty easy to put that all together and have something working after, I don't know, an hour of writing some code. So the cool thing about MIDI is it's been around for a really long time. It's a very simple, very standardized protocol. So you don't have to worry about drivers. It basically works everywhere. You can plug very different devices that say they're MIDI capable together, and they just work. I think each message in that protocol is just 3 bytes, or at least the actual core of the message is only 3 bytes. It's really easy to work with it. And yeah, you can plug your devices together, daisy chain them, things send messages and receive messages, and it just all works. It's really nice to work with. There's no complicated setups or anything like that. So if you already have any devices like I had, which I didn't buy it for the photography software, but I wanted to use it, and it's really easy to reuse those things for different purposes, even though most commercial software has just been written mostly for audio applications. And there's even libraries or code for things like Arduino or other microprocessors. So you don't have to run that stuff that I'm going to present on a computer. Well, for Python, you probably need a pretty standard normal computer, but you can do MIDI processing on a small microcontroller and just bit bang the messages out. And yeah, they're really cheap MIDI to USB adapters. So the MIDI connector, that's that one there. It looks a bit old. I mean, the MIDI protocol is really old, and computers don't really have that kind of connector, but it's really easy to connect it with USB and translate from MIDI connectors to USB. So yeah, there's mixer boards, there's pads, which are kind of like touch-sensitive drum, used for drum input. Piano keyboards is probably what you would think of first for MIDI-related controllers. And yeah, drum kits, so I've got some pictures there. It doesn't have to be audio, there's lighting consoles and lighting whatever controllers that use MIDI. And like I said, the cool thing is you can just all plug it in together and it works. So this one seems to have a computer built in, and it can probably run presets like lighting sequences. But if it didn't have that, if you don't want to spend the extra, I don't know how many multiple thousands of dollars to get that fancy version and you have something with just the sliders, you could let a computer running Python and the library I'm going to talk about do those sequences. And you're going to save a lot of money, and it should just work because it's also simple to put together. Yeah, musical keyboards, pianos. There's one where you can put your iPhone in and it will play music through or record stuff on your iPhone. It will probably output MIDI at the back as well. Drum kits look something like this, so they don't make much noise, but you can still play your drums. And again, send MIDI messages out, which means you can record your drumming on a computer. Not as sound, but as the actual notes. Could also look like this. And there's a lot of DIY home-built controllers. I think mostly like DJs or people that want to play a lot of samples, build things like that to quickly fire off certain sounds or events. So basically any kind of electronical component you could think of, sliders, knobs, encoders, trackpads like your mouse pad on a laptop, all of those. There's guitars with a built-in trackpad, and it can control your sound by sliding your finger around on the trackpad while you're playing guitar. So basically limitless opportunities to do stuff. So I'll quickly go through some of the theory of MIDI. Like I said, it's really simple. It doesn't take much to explain it, just to set the scene for what I'm trying to do with it. So the term controllers basically means it's like a keyboard, a mixer board, anything that will generate a MIDI message due to moving a slider or pressing a button or something like that. So technically a keyboard, a piano is a controller as well. Then software, like on the computer, can receive those messages, do stuff with it, process them, change them, send them out again, generate new messages. It's a bit of a gray area. Where does software end? Where do you call something hardware or firmware? Where is it software? It's all the same, really. And then there's synthesizers, at least in the audio world, that will receive MIDI messages and play a note, play some music. So piano keyboard thing is basically a controller and a synthesizer in one. You play your notes, it will output music, but it will also send MIDI messages to something else, like a computer, which the computer could play those notes, or you could send notes to the keyboard, and the keyboard will play them, output the sound. So again, lots of possibilities to plug things together. Play one keyboard, have the sound come out another keyboard, that kind of stuff. So that's basically what I meant with this picture. I guess it can get messy and very complicated, but you can have computers in the loop, different connections, all kinds of hundreds and hundreds of actual devices that you can buy, commercial stuff, all tied together with a fairly simple protocol that, so that's my main wall of text slide, just to quickly bring the gist out of MIDI messages. So there's different MIDI message types. You can have, I think, a total of 16, but I'm not sure if they're all used. And they can be sent on multiple channels. So channel 0 means broadcast. Every device that receives those messages physically will react to them. Or you can set a specific channel, and you can say your software should only react to incoming messages on channel 1. If there's other channels, ignore them. So that enables that daisy chaining. You can have multiple devices stuck together, but you can separate them with those channels. For some reason, I'm not quite sure why, but it's only using 7 bits for the data values. The most significant bit seems to be, or at least the examples I looked at, look just fixed to a 1 or 0 for certain types. So you only have a range of, your values can only be 0 to 127, which is good enough. I mean, MIDI's been around for a long time, and it works really well, and it's used in commercial applications all over the place. But 128 values for, finally adjusting certain things isn't that much. So that's one of the shortcomings of MIDI, and there are other things out there that will address that or replace it. And then there's, and on-off is just like, the lower half of the values means it's off for a button, for example, and the upper half means it's on for those values. And then there's different message types, and I'm only really going to talk about control chains messages, because that's what we want to do, control an application. So control change means a slider has been moved or a button has been pressed, that kind of stuff. Note on off, that's the stuff you would think of with playing a piano keyboard, electric keyboard. So pressing the key down is note on, releasing it is off, and it will also transmit the force you hammer down on that key. That's at speed. There's a panic message to shut off all notes currently playing, so if something goes haywire and your notes don't stop playing when you release your finger from the keyboard or something else happens, there's a message for just silencing everything. So it basically looks like this. There's 3 bytes, the type, the channel, and then 2 data values that depend on what kind of message it actually is. And just another very quick excursion, because before I actually get to the actual Python part. In Linux, if you do audio stuff, you probably won't use something like ALSA directly, but there's a jack audio server, which enables, with the right kernel, enables you to have real-time audio processing. So that's really important. And you can do cool stuff like virtual routing of your inputs and outputs. So in this example, you have at the left-hand side, the bottom, incoming, that's your sound card, capture, mic input, or line input. So I don't have a very fancy sound card there, so it only has those 2 inputs. And you can send them to other software that is running. So in this case, it's a guitar amplifier simulator at the right-hand top. And then the output of that, so this will simulate an amplifier, will output it to an effects unit. The effects unit will then send it to the playback output of your sound card. And you can swap that around and do it in different orders. And the more software you run, if you have a recorder running, a digital audio workstation, you can send it there as well. So once you get used to having those possibilities to reroute things, you really depend on it, and you can't really live without it. And you can do the same thing with MIDI. So for what I want to do, we only have to have the controller, which is called Nano Control 2. That's the one I showed at the beginning. Send it to our program, which is called mididings. Oh, that's the library, actually. But you can have outputs there as well and send it to other programs and so on. So there's a lot of flexibility, but you need that jack audio server to have that. So this is the software I wanted to use. The cat's not important. It's not about the cat. It's about the right-hand side. So there's a bunch of on-off switches and sliders for color channels and brightness and so on. I mean, lots of modules in there. This is to develop raw photo files from your camera and turn them into JPEGs. And basically I thought, oh, I've got this mixer board. I want to control those things all at once. I don't have to click around and find the right module. I can just say brightness up, brightness down. That would be nice, but the software doesn't have any API to do that, or it doesn't talk MIDI, because non-audio applications usually don't. But it has a really good shortcut, well, like most professional or semi-professional software, I guess. It has a really good shortcut system, like you can access any function via keyboard shortcuts. So I thought maybe I can receive MIDI messages, react to them by sending shortcuts, and this will just do what I want the application to do. The only downside is it means the application has to be in foreground, but usually if you do stuff with it, this will be the case. So I shouldn't have highlighted the reset one, because actually what I use the most is the edit row of each function. So for example, exposure, that's the brightness. I can define a shortcut to edit that value in the software. So 0 means just the way the camera recorded it. I can do +1 and it will make it brighter, or -1, and so on, to make it darker. So edit means if I press that shortcut, a small window will pop up. I can enter a value, for example 1, 1.5, 0.3, press enter, and the software will take that value. And actually, if you automate that, it will happen so quickly you don't even see that edit window. So when I move my slider in the end, I don't see a window popping up and some numbers magically appear. It's just so quick, it just happens right away. The only limitation is that my computer is actually a bit too slow for heavy lifting, raw processing, so it takes a few seconds for the photo to actually reflect what I've done, which can be a bit annoying, but with a really grunty good machine, this wouldn't be a problem. Yeah, the alternative would be a good API. I thought about, can I do Darktable as open source? Could I hack that to support it? But actually, it would probably be more work, and then you're still limited to this one software. So there's a library called mididings for Python, and it talks MIDI, and you can write code like this. So this looks like pretty normal Python code. Import some stuff. You have a function there that filters on the channel and the type of the message, and then it will invert that value of that message, and velocity is how hard you hit a key. So this basically means if you hit the key hard, it's really quiet. If you just gently touch it, it will be loud. Invert that message and send it out again. Pretty standard stuff, but mididings can actually do much more. And if you want to write a lot of code with lots of message processing and different presets and so on, it will get pretty tiresome to do it this way and pretty hard to read. So actually, it also implements a domain-specific language, which is probably clearer with an example than this standard definition of a DSL. So it can look like this. The top two lines are not too important. It just says piano is on this output and strings are on this output. But you can filter the channel, so only react on messages on channel 1. Send this, so this is the domain-specific language part. Those symbols are not really part of normal Python. Send them to another function that does something to them. Key split means lower half of your keyboard will play one instrument and the upper will play a different one. And then send that out the computer to whatever is connected. It gets crazier, so you can do the top one again, that's pretty similar. Filter on a certain message type, send it out a different channel. The middle one is filter, so it means only apply the following stuff to this message type, note on, so pressing a key. Transpose it down 1 octave, and then play it in parallel through 2 instruments, which are orchestra and bells here. So more elements of a very specific language for this domain. A different way to write it is the bottom part, which is using a dictionary. Again, like filtering messages by type and then doing certain actions to them. It gets even crazier. I've got an annotated version of that as well. I mean, you do a lot of filtering. You say, I only care about this specific language, and then I want to do something to that, or read it, or send it out again slightly modified. So yeah, you can do a lot of filters like that. And it basically provides filters and methods for every part of a MIDI message you can think of. Like you can filter it on the slider has to be in the middle, or it's not allowed to be in the middle of its position, which basically means like from 50 to 100 value. So you can filter on all those things. I'm not going to spend too much time on that anymore, but if you're interested in any MIDI processing, I would really look at that library because there's so much you can do with it, and it's really nice to use. You can change values, not just say transpose down by a fixed value. You can apply multipliers and curves to it, so you can make, say, a linear slider. You can turn it into a non-linear slider if that's what's more useful to you in your application. Oops. So yeah, I haven't actually, so that code is on GitHub, but I actually haven't implemented some of those really useful functions I found while I was still preparing those slides and researching some of the API. So I should probably use a bit more of that, and I'll look at that when I get back from Kiwi PyCon. But yeah, remapping values and changing those curves, those values, lots of really useful functions in there. So that was all introduction to basically how do I get to what I want to do and how did I put it together. So what I want to do, it's actually pretty simple, and it's not much code because it all relies on those libraries and like a threading library and all those things that are already in Python. I want to collect incoming messages, maybe do some filtering, but basically just, oh, there's a message stored. This is the producer, basically, in a consumer-producer sense. Then another thread that will grab events that are waiting and do something with them, so turn them into a shortcut. The way I do that in this asynchronous consumer-producer thing is that, like I said, especially on my computer, which is not quite strong enough for heavy lifting, raw editing, it takes a few seconds for certain actions to actually complete. And if you have other messages going on, you don't want your whole application to block. You still want to receive other incoming messages. So you need some threading. And yeah, there's another part which uses another library or another program to actually send off that key press to your window manager, to Windows, to macOS. So this is just code snippets and little bits that I put together for the slides. If you look at the actual code, it's all wrapped up in classes, and it should be fairly abstracted away, so you can hopefully, or maybe someone can make it run on other systems than what I wrote it for, which was just Linux. So collecting is just, we have a queue and we put new MIDI messages in there. Maybe filtered on, I only care about control messages or something like that. Then grabbing them, so another thread, like I said, will grab those messages, go through them. So we'll just get all the stuff that's in the queue. So events is a queue class in Python. Grabs all those that are waiting, releases a lock, and then goes through that list and turns them into keyboard shortcuts. So this is the heart of the program, basically. There's a big dictionary. Eventually, maybe it should live in a config file or something else, but right now it just sits in the Python code. It's a big shortcut map that will turn MIDI messages, which are basically the key in this dictionary, so the left-hand side, into keyboard shortcuts using some classes that are in my code. So the key here is a tuple. The first number is the channel. 0, like I said before, MIDI channel 0 means just any message. React to any message. Then control messages, so that's the stuff with sliders, knobs, buttons, not keyboard presses or panic messages or something like that. And the 11, that's in this case, that means control number 11, slider number 11, button number 11, whatever. So with most of those, so with those mixer boards, you can usually assign control numbers to each control individually. It's all configurable. And then, yeah, the right-hand side's a window. That's the window name. So if I want to make sure that if I'm in a different window, say Firefox, and I accidentally move a slider, even though I didn't intend to, it shouldn't do anything in Firefox. It might actually do something bad. Like if one of my shortcuts is, I don't know, Control Q, I don't want to happen that to happen in Firefox because it would close it. So I filter on, I make sure before I send off the keyboard shortcut, it's actually the right window is in the foreground. And then your shortcut action, that's a class, or there's some classes, some hierarchy of classes that can run certain shortcut events or other things you could think of that you could have there as classes, which I don't have yet, is like a mouse action, mouse move, mouse click. So at the bottom there is a short definition of how those classes look like. They take modifiers, so Control, Alt, Shift, the actual key, and also optionally a function which can, because the MIDI messages, the values are only 0 to 127. For your program, your application, or in my case, Darktable, probably doesn't just want to set I don't want to set the brightness of a photo from 0 to 127. I want to set it in fine increments from -1 to 1, or from -3 to +3. So I have to translate those incoming values into different values. So you can do that with a little lambda function or some small function you stick in there. And there's also a shortcut action sequence, which is just daisy chaining multiple shortcut actions together. And then you can run it. And the way I do that is there's a program, again, for the X Windows system, Linux. There's a program called XTE, or X Automation. And if you run that on a console, it will wait for some standard input. And it has like a little MIDI language you have to input to make it do key presses. So key down control, press down control, send the key O, release control, and then enter the actual value. So that's with that pop-up in Darktable, it will expect me to enter a value that I actually want and press enter. And that's basically the whole sequence. You need to do that. And like I said, it happens so quickly I don't even see that window pop up. It just seems like the slider is directly controlling the software. But it's not, it's actually sending key presses. So I was surprised how well that worked. And using the Python library subprocess to send that off and send the standard input to XTE. So a few things. So it was all pretty quick packed together. It's not. I hope it's good code. It's got nice classes, and it should be ready to be expanded to, say, other operating systems or something that wouldn't work with. That XTE is the main thing that I think wouldn't work on other operating systems. But like I said, MIDI isn't perfect either. So especially that range of 128 values isn't very much. It seems to be fine. It seems to work for most applications, even like most commercial applications. But it's not very much. And there's a successor protocol called OSC, which will at least live in parallel to MIDI for, well, started, it's already out there. And mididings can send those protocols as well. I'm not quite sure if it does input, if it processes input in OSC as well, or if you need a different library for that. Knowing Python, there will definitely something out there. But that support is coming into those libraries slowly as well. Yeah, it'd be nice if someone is interested in that. Hopefully they can extend it to another OS. In theory, you don't have to use mididings. It could be another library as well. Should be all fairly easy to put together. I've written it mostly for Darktable, and those keyboard shortcuts, the way they work, are written for that piece of software. I've done a little bit for GIMP as well, which is different. So if you want to change, say, the brush size of something, of a brush, in GIMP, the keyboard shortcuts to do that look quite different. So I had to adapt the code a bit to make it more flexible, and I noticed the first attempt was way too specific for that one program I started with. And it will happen again if you add another software. You could think like sending off sequences of keys could be used for games, maybe. If you might have to adapt the code just to do exactly what you want. It might not be flexible enough. I'm not really doing any mouse stuff yet. I don't think it's a good idea to start controlling GUIs automated with mouse input. But maybe you have to, or maybe there's something where you can, I don't know, just double click or something like that. You could do that with everything that's there as well. It's just not in my code yet. And MIDI can do another cool thing, which is feedback. So if your controller, your mixer board supports it, the software can actually talk back to it and move the sliders if they're motorized or light up LEDs. I'm not doing any of that yet, and I'm not quite sure if my controller even supports that because it's quite a cheap one. But there's another possibility that when I load my photo editing software, whatever the sliders in software are set to, it will set the controller sliders as well, which would be pretty cool because it means you actually see physically what your software is set to, and you can start from there. You don't have to fiddle around and set them to the right value when you start. But it's like another fancy feature that so far I haven't really needed. So in terms of references, just a few ones. MIDI.org that's where you find the specification and info on MIDI, Wikipedia, and so on, of course, as well. My program's on GitHub. If you just look for Tobi W, you'll find it. There's sadly, not too much out there yet on my GitHub. And mididings, it's really well documented, and just apt-get install python-mididings works as well. So it's in Debian and Ubuntu. So you find me on GitHub, Tobi W. I hang around on the NZPUC IRC channel as well a little bit, and Jabber email. It's all there. Thank you. Does anyone have any questions?
So actually, you said that you were trying a little with GIMP.
Yeah.
And when you were speaking already about shortcuts, I thought I'm not sure about the current version of GIMP, but I remember there was an idea of writing extensions to GIMP in Python. Mm-hmm. So maybe you can skip this idea of controlling, using the shortcuts and mm-hmm. get directly to the API this way.
Yeah.
Because I understand that with the Darktable, there was no way of extending it. Mm-hmm. And then when you tried with GIMP, you just went with the same principle.
Yeah. I mean, yeah, GIMP was just like, oh, what other program do I sometimes use that I could use the same method? And it kind of worked, but it wasn't very, very fast and very nice. So if there's a better way, that'd be great. Or it sounds like there is, so I'll definitely look into that.
As well, I would feel like, for example, graph manipulation would be very nice with this kind of tools, mm-hmm. just like moving along some scientific data. Mm-hmm. So maybe this is the place where you could explore. Yeah, it's good ideas. Yeah, thanks.
I'm sorry, there's only time for one more question, but if you have any more questions, we're about to have afternoon tea. So I'm sure.
Yeah, I don't want to stop anyone from going out and eating food.
That looks awesome. I really like. I think it's such a great idea. Do you use it in anger, and how has it changed how you process photos?
Yeah. So one problem, like I mentioned a few times, is that slow computer. It's not. Well, in general, that editing photos is not huge fun to do. I have to upgrade that at some point as well. It would be much nicer, and I would use it much more if moving a slider would directly within milliseconds or half a second reflect on it. So I haven't used it heaps, but it's ready to run. And if I feel like I'm going to edit a few photos, I will use it. It definitely works, and I hope I can extend on it and with a better computer at some point and a bigger desk to have space for all those extra controllers. Yeah. Use it more. I could use it more.
Could you all join me in thanking Tobi?